Example 2, now we're going to find equations of a line through 2 points. So find parametric and symmetric equations of the line that pass through the points -2, 1, 0, and 1, 3, 5. So what we're going to do is call this first point, this will be P, and then this will be Q. So let me just write that. So P equals -2, 1, and 0, and then Q is 1, 3, 5. So remember Q, this is going to be our X, Y, and Z. For P, this will be X sub 1, Y sub 1, Z sub 1. And so to find the vector PQ, that is going to be our terminal minus our initial. So again, we're looking at this terminal minus our initial. So this is going to be 1 minus a -2, and then 3 minus 1, and then 5 minus 0. So the vector PQ is 1 minus 2, 1 minus a -2 is 3, 3 minus 1 is 2, and 5 minus 0 is 5. So now this is our vector, and so this is A, B, and C. So the parametric equation now, we'll do what we did earlier. So X equals X sub 1, which is -2, and then plus A, which is 3, T. Then we have Y equals X sub 1 is 1, and then plus 2 times T, and then Z is going to be Z sub 1, which is 0, and then plus 5T. Now let's look at our symmetric equations. And so that is going to be X minus X sub 1, which is X minus a -2, or X plus 2 over A, and then A is 3. And so that equals Y minus 1 over B, which is 2, and then Z minus 0 over 5. So here's our symmetric equations. Let's go ahead and try this example here. Find the parametric and symmetric equations of the line that passes through the points 1, -6, 3, and 3, 5, and 8. So trying this out, vector PQ would be 2, 11, and 5. Your parametric equation would be X equals 1 plus 2T, Y equals -6 plus 11T, and Z equals 3 plus 5T. The symmetric equations would be X minus 1 over 2 equals Y plus 6 over 11 equals Z minus 3 over 5. So now we're going to find standard equation of a plane in space. The plane containing the point x1, y1, z1 and having a normal vector n of a, b, c can be represented by the standard form of the equation of a plane. So we have a times x minus x sub 1 plus b times y minus y sub 1 plus c times z minus z sub 1 equals 0. So we're going to use that to find an equation of a plane in 3 space. So find the general form of the equation of the plane passing through the point 1, 3, 6 and perpendicular to the vector n of -3i plus 2j plus k. So we're just going to label this as A, B, and C, and this point P, we're going to label that as x sub 1, y sub 1, z sub 1, and all we're going to do is plug it into this equation here. So this is going to be -3 times x minus x sub 1, which is 1. And then we have plus b, which is 2, times y minus 3 plus 1 times z minus 6, and that equals 0. So then we distribute and simplify. So this is going to be negative 3x, and this is negative 3 times negative 1, which is a positive 3. Then we have plus 2y minus 6, and then plus z minus 6 equals 0. Then we need to simplify, and so we have negative 3x stays the same. Then we have 2y, 2y, that's done. And then we have a plus z. And then we have 3 minus 6 minus 6, so that is going to be negative 9 equals 0. So that's the equation of a plane in 3 space. So now try this example on your own. Find the general form of the equation of the plane passing through the point negative 2, 1, and 3, and perpendicular to the vector n equals 2i minus j plus 6k. So if you plug it in, you would find that the equation would be 2x minus y plus 6z minus 13 equals 0.